So for our next example, we're going to take our composite shape and split it up into a number of rectangles. This can be achieved by dividing the I-beam with two horizontal lines so that we can split the I-beam component into three rectangles. Here there's a plate welded to the bottom of the I-beam for added strength. Starting at the top, we label the first rectangle number 1, then number 2, number 3 and number 4 at the bottom. To work out the position of the centroid for the overall shape, first we must specify where the centres are for our individual rectangles. First centre is located here. Second centre, third centre, and the centre for the last rectangle is located here. And what we must do is be able to specify the locations of these individual centres relative to one reference point. The reference point we choose is the bottom left hand corner, and this reference point is like an origin on a graph. Here the reference point has coordinates 0, 0, and we measure the centres for the rectangles relative to our reference point. Starting with the first rectangle, we're going to calculate where its centre is relative to the reference point and state a set of coordinates. So here the distance across would be half the width, which would be 66, and then the height to the centre for the first rectangle would be the 6 plus the 10 plus 187 plus half of its height, and that gives you a total distance of 208 millimeters. We'll write this to the side: 66, 208. Now repeating the same for the second rectangle. Distance across to its centre will again be 66, and then the distance, vertical distance up to its centre will be the 6 plus the 10 plus the half of 187, and that would give you a total of 109.5. We'll write these coordinates just to the right hand side. For the third rectangle, again, distance across to its centre will be 66, and then the vertical distance up to get to that centre will be the 6 plus the half of the 10, which is 5. That should give you 11 for the height. We'll write these coordinates just to the right hand side: 66, 11. And for the fourth rectangle, distance across is the half of 286, which is 143, and then the distance, vertical distance in this case, is going to be the half of the 6, which would be a value of 3. We'll write these to the right hand side: 143, 3. Beneath each set of coordinates for the centres, I'm going to write down the variables x1, y1 for the first set, x2, y2 for the second set, x3, y3 for the third set, and x4, y4 for the fourth set. To work out the position for the centroid for the overall shape, we need to combine together the four centers with the areas we have for each of the shapes. To do that, we have two equations we use. X bar is sigma AX over sigma A, and the other one for the y coordinate is y bar is sigma AY over sigma A. Starting with the first one, X bar, more completely, the formula for it would be area 1 times the distance x1 plus area 2 times the distance x2 plus area 3 times the distance x3 plus area 4 times the distance x4. We have 4 parts in this formula because we have 4 rectangles. Then divide that by the total cross-sectional area for the shape, which will be area 1 plus area 2 plus area 3 plus area 4, all added together. Now filling in some values we have for the areas and for distances x1, x2, x3, x4. Area 1 is 132 by 10. The x1 distance we've already written down to be a value of 66. For area 2 is 6 wide and 187 tall. The x2 dimension is a value of 66. For rectangle 3, its dimensions are 132 by 10, and its x3 dimension is 66. The last rectangle is 286. It is 6 millimeters tall, and the x4 dimension is 143. This all gets divided by the total cross-sectional area, which is 132 by 10 for area 1, 6 by 187 for area 2, 132 by 10 for area 3, 286 by 6 for area 4. Now, using your calculator, you can work this out. That would give you 493,680 over 5478. If I work that out, that would give you 90.12 millimeters for the location X bar. Now, repeating the same process but for Y bar, here the complete formula for Y bar will be area 1 times distance Y1 plus area 2 times distance Y2 plus area 3 times distance Y3 plus area 4 times distance Y4, all divided by the total cross-sectional area for the shape, area 1 plus area 2 plus area 3 plus area 4. Filling in the values we have, area 1, 132 by 10, and the Y1 dimension that we've already given is 208. For area 2, 6 by 187. The Y2 dimension is 109.5. area 3, 132 by 10. The y3 dimension is a value of 11. And then area 4 is 286 by 6. And the y4 dimension is a value of 3. Divide that by the total cross-sectional area, which will be 132 by 10 plus 6 times 187 plus 132 by 10 plus 286 by 6. Using your calculator, you can work this out. 417,087. Divide that by the total cross-sectional area, 5478, and that would give you a value of 76.14 millimeters. So our answers are X bar 90.12 millimeters and Y bar 76.14 millimeters.